Hello everyone, welcome to the next set of 5 questions. Question number 186. An alternating voltage is given by V equal to 100 sin 314t volts. Its average values. So average value of a sinusoidal wave is Vm by 2 Vm by pi. Okay, so here from this equation it is clear that the maximum value is 100. So V average is equal to 2 Vm by pi is equal to 2 by pi into 100. 2 by pi value is 0.637 into 100. So it becomes 63.7. Option D is the right answer. Here you have to by heart some numericals like 2 by pi is 0.637. 1 by pi is 0.318 and also 1 by root 2 0.707. 1 by root 3 is 0.577. So if you know such kind of values, then objective type questions will be very easier for you when you deal with such kind of numericals. Okay, now next question is 187. What is the approximate peak value of an alternating current producing 4 times the heat produced per second by a steady current of 2 ampere in a resistor? So heat produced by a steady current of 2 ampere. Steady current means DC current. So heat produced by a 2 ampere DC is equal to I square RT. We know the basic equation, and I value is the DC value, which is 2. So 2 square R into what is the time given? It is per second into 1. Okay, so it is 4R. Heat produced by a 2 ampere DC value. Okay, now we have to check the question current. I mean the alternating current. What is the approximate peak value of alternating current? So that current produces 4 times this 4R. So heat produced by our alternating current is equal to 4 times the heat produced by this steady current. So 4 into 4R, that is 16R. Now what is the equation for heat produced by alternating current? If it is an alternating current, then again it is I square RT itself, but here instead it is I RMS square RT, or the effective value. IRMS is the effective value of the current, isn't it? So IRMS square RT is equal to 16R. And we know again time is equal to 1 second. So IRMS square R into 1 is equal to 16R. IRMS, you get it like IRMS square is equal to 16. IRMS is equal to 4. Now what is the value for? We have to get the peak value or the maximum value. So what is IRMS? It is I max divided by root 2 equal to 4. So I max is equal to 4 root 2. What is 4 root 2? A little greater than 4, isn't it? Now check among the options. It is option B. 5.6 is the right answer. Okay. Now the next question. Question number 188. An alternating current has a maximum value of 120 ampere. What is the instantaneous value after 1 by 360th second? So instantaneous value equation. I is equal to Im sine 2 pi ft. Im maximum value given is 120 sine 2 pi into frequency is 50 hertz. Time is 1 by 360. Time is 1 by 360. So 120 sine 250 100 pi by 360. Now whatever is inside this bracket is in radians. So convert into degree for easy calculations. If you need to convert to degree, multiply it with 180 divided by pi. Solving, you get 100 by 2, that is sine 50. Now 120 sine 50. We do not easily get the value for sine 50. So we know that sine 90 is the maximum value, which is 1. So sine 50 is little less than 1, isn't it? And we also know that sine 45 degree is 0.707, 1 by root 2. So what is in between 0.707 and 1? It would be like 0.8 something. Okay, because the sinusoidal waveform is like this. It is here the angle will be 90, and here and all it will be 50. So our value will be something less than 1. So 120 into something less than 1. Now check among the options. This is in 1000 range. So we can neglect this. And this is in 10 and this is in 1. So 103.9. This is comparatively lesser than 120 is right among other options. So option B is the right answer. Moving on to question number 189. An alternating voltage V is applied across a resistor of 100 ohms. An AC ammeter connected in series with the resistor will read. Okay, so ammeter is connected in series. Anyway, so ammeter is going to read the current passage through this 100 ohms. So V by 100 is equal to the current, and we know that ammeter reads the RMS value. So V RMS by 100, that is VRMS is the maximum value by maximum value is 282.8 divided by root 2 is the maximum is the RMS value, and the denominator we have 100. So it is 282.8 divided by 1.414 into 100, that is 282.8 divided by 141.4, which is 2 ampere. The last question, question number 190. In an AC circuit, V of t and I of t is given. The PF of the circuit, the power factor of the circuit. Okay, we know that the power factor is cosine of the angle between V and I. V and I, or power factor, this is the power factor equation. Power factor is actually the useful power divided by the apparent power, whatever power is there. Okay, useful power by apparent power. So mathematically it is cosine of the angle between V and I. So let's see, voltage is 20 sine 314t plus 5 pi by 6, and current is 10 sine 314t plus 2 pi by 3. So we have to compare this and get the angle between V and I. So always check if both are in sine representation or cosine representation. Okay, if you have a combination of sine and cosine, you have to convert into any one. Now, since both of these are sine wave, we have to just compare what is given inside the bracket. We have to not worry about these values because these are the peak values not in use. We have to just compare the angle values or the phase values. Okay. So, this is 314t, this is 314t. Now, the angle here is 5 pi by 6. So, if I draw this V value, voltage value is, if this is 5 pi by 6, and where can I represent this 2 pi by 3? 2 pi by 3 means I will multiply both with 2, so it becomes 4 pi by 6. So, if this is 5 pi by 6, current is going to be behind this voltage. Current will be somewhat behind this voltage. So this will be 4 pi by 6 because we are having an anti-clockwise rotation of phases. Now this is your current. So what is the angular separation? 5 pi by 6 minus 4 pi by 6, that is pi by 6. Pi by 6 means 30 degree. Now the power factor equation is cos angle between them, that is 30. Cos 30 is root 3 by 2, or it is 0.866, and so 0.866 is the answer, that is option A or B. Now what is this, lag or lead? We have to check whether the current is leading the voltage or lagging the voltage. Here current is behind the voltage, so 0.866 lag. Option A is the right answer. So we'll be coming back with the next set of questions. Thank you.